Students, now we are going to solve exercise 1.2 class 10 advanced maths question number 11. Up to question number 10 already we have solved through the video, and now in this video we are going to solve exercise 1.2 class 10 advanced maths question number 11. If a product b equal to m comma 1 n comma 3 m comma 3 n comma 1 m comma 2 n comma 2, then find a and b. We have to solve this one. Now let's have a look how to solve this one. Student, now here I am going to write that exercise 1.2 class 10 advanced maths question number 11 solution. Okay, now given part is here, given part is a product b. This is the given part in the question at m comma 1, then n comma 3, then m comma 3, then n comma 1, n comma 1, then m comma 2, then n comma 2. This is the given part. Students, one thing you must remember that these values are the a product b. We have to find out a and b, which means maybe you have seen that in my earlier videos. While a and b elements are given, we normally used to find out the a product b or b product a, but here a product b is already given, which means answer is already given. We have to find out a and b from here. So it's very easy actually. So look, in every elements m and n is there, so a equal to, we can say that therefore a equal to m comma n, and b equal to 1 2 3 1 2 3. This is the answer of the question number 11. Students, now we are going to solve question number 12. If a and b be non-empty sets and a product b equal to a product c, then show that b is equal to c. We have to find out now question number 12. Now let's have a look how to solve this one. Now student, write down that number 12 solution. Number 12 solution now. Okay, here first of all we'll write here means x or y. If I take y an arbitrary element, or we can take that x is also an arbitrary element. Now what is the meaning of arbitrary? Arbitrary means any of the any elements. Okay, now here in the question already mentioned that a and b are the non-empty set. Non-empty set, I repeat again, non-empty, which means a and b has some element. That's why a and b are non-empty set, and condition is given a product b equal to a product c. Then we have to show that b equal to c. So let's start here then. Let y be an arbitrary element. Arbitrary means any element. Arbitrary element of b. So therefore we can say that y belongs to b. It is obviously because if y is the element of b, so we can say that y belongs to b. Now in the next step, if I write here x comma y belongs to a product b. So if y belongs to b, then x belongs to a product b. X comma y belongs to a product b, which means if y belongs to b, then x belongs to a. That's why a product b belongs to, sorry, x comma y belongs to a product b. And here I will write the condition. This symbol is indicated that for all x belongs to a. This symbol is indicated for all x belongs to a. Now in the next step, in the question it is mentioned a product b equal to a product c. So Here I can write A product C also, because since A product B equal to A product C, it is given in the condition. Now look one more thing. Since X belongs to A and Y belongs to B, but here A product C, which means X belongs to A and Y belongs to C. Y belongs to C. I repeat again. Initially, we took y is an arbitrary element of B, means any element of B. Now y belongs to B. Okay. Now x comma y belongs to A product B. So x is the element. Here the condition written for all x belongs to A, means value of x or x belongs to A. So x comma y belongs to A product B. Now in the condition it is given in the question A product B equal to A product C. So if A product B equal to A product C, then x comma y belongs to A product C. In place of A product B, I may write A product C also. Now look, x belongs to A here, x belongs to A here, but here y belongs to B, but here y belongs to C. Now, so we can say that therefore, sorry, since B and this symbol is, I am taking this one as equation number 1. Now student, look, I have used one symbol here. This symbol is this. If we use the symbol in the set theory or any problem of the set, so we can say that B included C. I repeat again, B included C, which means Y is a element of B, but here we have proved that Y is an element of C, which means B included in C. This is our equation number 1. Now in the next part, initially I took x, now I am taking y. Now let's have a look how to solve this one by taking x now. Again, let x be an arbitrary means any element, arbitrary element of C, means of the set C. Okay, now so therefore obviously x belongs to C. Now look here, so here I will write x, y comma x belongs to A product C, and obviously the reason for all y belongs to A. Now look, y I have taken one element, so y belongs to A, then x belongs to C, but in place of A product C I will write here A product B. Also condition given here, since A product B equal to A product C, this is the condition given in the question. So now students, look one more thing here, y comma x, and now students we can say that, so y belongs to A and x belongs to B. Look here, x belongs to C here, but now we are proving that x belongs to B. Now look, so here you can say that C included in B. This is our equation number 2. Now look student, don't confuse. Initially I am repeating this answer again. Okay, now let me write the last line. Okay, therefore from 1 and 2 we can say that B equal to C, hence proved. This is the proof already. Now student, look, I am repeating the answer again. Look student, let we have taken y be an arbitrary element of B, then y belongs to B obviously. Now we have taken x comma y belongs to A product B. For all x belongs to A, now in place of x comma y belongs to A product C, as because the condition given in the book A product B equal to A product C, that's why in place of A product B we have used here A product C. Now obviously y belongs to B, now here y belongs to C, so I have written here y belongs to C. Now B is included, this symbol is called B is included in C. Okay, now this is the first portion which you have done with the value of y initially. Now look, again I am going to change the pattern now. In place of y, I will take x now. Look student, again we have taken x be an arbitrary element of C. Now here x belongs to C obviously. So y comma x belongs to A product C. For all y belongs to A. Since x belongs to C, is obviously y belongs to A. Now here in place of A product C, I am using A product B. Why? Because this is the condition given in the question. A product B equal to A product C. So y comma x belongs to A product B. So in place of A product C, I am using A product B. So y belongs to A, then x belongs to B obviously. Look here, x belongs to C. Initially you have took. Now x belongs to B now. So C is included in B. Equation number 2. In equation number 1, we have shown that B is included in C, and in equation number 2 we have seen that C is included in B. So obviously from 1 and 2 it is clear both the elements both the set B and C both are included with each other. So it is clear that B equal to C. Now students, look that question number 13 from exercise 1.2 class 10 advancements. Here given A equal to 1 comma 2 the element of A, B equal to 1 3 2 the element of B, and C equal to 4 2 1 the element of C. We have to show that A square equal to B square intersection C square. So it's very easy actually students. So we have to find out A square first, then B square, then C square, then after that we have to go for the intersection. Now let's have a look how to solve this one. Now student, look the answer how to solve this question number 13. Okay, now I'm writing here 13 solution. Okay, now look student, how to solve this one. First of all, given, what is the given part? A equal to 1 comma 2, B equal to 1 3 2, and C equal to 4 2 1. Here we have to find out A square, means A into A. Now look, 1 comma 2, again 1 comma 2 means A product A. So if we want to find out A product A here, then 1 comma 1, then 1 comma 2, then 2 comma 1, then 2 comma 2. This is the first one, A square. Now B square, look how to solve this one. B square now B product B. Now 1 3 2, 1 3 2, this is the element of B. Now go for it again, then 1 comma 1, then 1 comma 3, then 1 comma 2, then 3 comma 1, then 3 comma 3, and next one would be 3 comma 2, then 2 comma 1, 2 comma 3, and 2 comma 2. This is the B square. Now the last one, we have to find out C square. Let's have a look now how to solve this one. 3 square, sorry, C square, not 3 square, C square now, C. So here C square, which means C into C. So initially we have to put the elements of C, 4 2 1 product. Here is 4 2 1. Now look student, just after that 4 2 1 here. Now go for the multiplication, 4 comma 4, then 4 comma 2, then 4 comma 1, then 2 comma 4, then 2 comma 2, then 2 comma 1. Okay, now after that 1 comma 4, then 1 comma 2, then 1 comma 1. These are the elements of a square, b square and c square. Now we have to find out that a square equal to b square intersection c square. Now let's have a look the next portion. Students, now we have to find out first that b square intersection c square. So value of b square, value of b square is, look here, value of b square is 1 comma 1, then 1 comma 3. Okay, I am writing the value of b square here, then I will go for it. Okay, value of b square 1 comma 1, then 1 comma 3, then 1 comma 2, then 3 comma 1, then 3 comma 3. Okay, then 3 comma 2, then 2 comma 1, then 2 comma 3, then 2 comma 2. This is the value of b square only. Okay, now student, I am using the intersection sign here, intersection. Then I am writing here the value of c square. Here value of c square, c square is 4 comma 4, then 4 comma 2, then 4 comma 1, then 2 comma 4, then 2 comma 2, then 2 comma 1, then 1 comma 4, then 1 comma 2, then 1 comma 1. This is the value of c square only. Now we need to find out the intersection. So we know that the method of intersection is, we will take the elements which are common in both the set. Now students, let's have a look which are the common part here. Common part means, so we'll write here 1 comma 1, 1 comma 1 common, so here 1 comma 1. Okay, now next part is 1 comma 2. Let's have a look, 1 comma 2, and here 1 comma 2 is common, so 1 comma 2. Now next one would be that 2 comma 1, so 2 comma 1 is common here, then again 2 comma 1 is common, so 2 comma 1. And last one would be 2 comma 2 is common. Let's have a look, 2 comma 2 is common, here also 2 comma 2, 2 comma 2 is common. In intersection we'll take the elements those are common. Now after that, students, look here. Now all the elements of b square intersection c square are belongs to the a square, all the elements. So in place of, I repeat again, in place of, here I may write here a square. This indicate that, this indicate that, therefore a square equal to b square intersection c square, hence proved, hence proved. Now student, the last question, 1.2 exercise, class 10 advancements, question number 14. If a equal to 0.0, the element given, we have to find out a product a. So initially we'll do a product a, then with that value we'll go for the further product of a. Now let's have a look how to solve this one, the last question of 1.2. Now next one, 14, solution. Given a equal to 0 comma 1, we have to find out a product a. So first of all we'll go for a product a only. So let's have a look now, 0 comma 1 product 0 comma 1. Now here, now 0 comma 0, then 0 comma 1, then 1 comma 0, then 1 comma 1. This is a product a only. Now with this value we are going to multiply the further product of a again. So a product a, which means a product a value is 0 comma 0, then 0 comma 1, then 1 comma 0, then 1 comma 1. With this we are going to product of the further one means 0 comma 1. So let's have a look now how to solve this. Here Now 0, 0 comma 0 comma 0, 0 comma 0 comma 0, the first one, and next one is 0 comma 0 comma 1. Next again 0 comma 1 comma 0 and 0 comma 1 comma 1. Okay, now after that here 1 comma 0 comma 0 and 1 comma 0 comma 1. Next here is 1 comma 1 comma 0 and 1 comma 1 comma 1. This is the answer of the last question.